Welcome to the 302 how-to video for the 555 timer lab. Okay, let's add an oscilloscope, and this circuit is done. Okay, so what you need to do for this, I'm going to give you this file, and it's going to be under 555 one shot. Let's see. And this will be available on Canvas. And what you're going to do is you're going to change this resistor by double clicking and change the value based on what I ask in the lab. Here's our capacitor you're going to change. Do not change the trigger resistor value, and don't change our voltage capacitor. Okay, let's test our retriggerable one shot. And I've lowered this capacitor in order to get a shorter pulse out. So let's start our simulation, open up our scope, and scope is on. 10 volts is reasonable because we have 10 volts in. Our pulse is going to be 10. I got 50 milliseconds width there and should be in the range. So let's see if we could get this guy running here. All right, we're going to click on the page, make sure our switch works. Close, close, open. There we go. Let's single sequence. Let's try again. Single sequence, close, open. There we go. And let's go ahead and measure this. This one is 50 milliseconds, so we've got 1, 2, which is 100, maybe 120, and we could go to measure, and let's go to positive width. And we have 109 milliseconds. Pretty good guess. Okay, and that is based on the calculation based on these two. Okay, our scope may not be readable as it is, so let's use my snip tool and let's get a larger view. And let's shut down our scope. And there we have our 109 millisecond pulse. And you notice every time that I re-triggered it, it would restart. Okay, so let's try this circuit out. Let's start the simulation, turn on our scope. We're going to, there we are. And we have, whoops. Let's try again. Let's go to run. There we go. And there we have our continuous wave. This is called an astable multivibrator because it has a continuous wave. And let's go ahead and go to single. Now let's try again. Here we go. Alrighty, so here we have our output. And with these resistors and capacitors, we could change the frequency and we could change the width. The positive width is always going to be greater than the minus width because of the way the circuit's set up. So let's go ahead and go to measure. And we got the positive width. Well, let's go ahead and get the negative width. Okay, and let's get the frequency. 4.8 kilohertz. and we might as well get the period. Okay, this may be difficult to see, so let's go ahead and get my snipping tool again. Move him out of the way, and what we have is our positive width 69, or excuse me, 138, our negative width 69.5, our frequency 4.8 hertz, and our period is 208 milliseconds, and that is our wave. And so let's go ahead and take a look at our capacitor. Okay, let's take a look at our capacitor charge pattern. So let's turn on our blue, and let's go ahead and snip it out again. Okay, so what we have here is hopefully a clear picture of our waveform. So here is our output. The blue is this capacitor charge discharge curve. And you can see where it charges when on the positive pulse, and it discharges on a negative pulse. And if we look closely, this goes from 1/3 VCC to 2/3 VCC. That is based on the insides of the 555 timer. So our capacitor is charging, discharging, and it's triggering the output signal.